My name is Nemanja, and today we are talking about abstract factory design pattern. It's one of the creational design patterns. Have you ever built a code that creates an object, but later when you needed to add support for a new type, you needed to rewrite the whole thing? That's where the abstract factory design pattern comes in place. We have already shown factory design pattern, which is used to create objects using factory class. Abstract factory design pattern is pretty much similar but more advanced. Abstract factory design pattern is a creational design pattern that is used to create groups of objects without specifying their concrete classes. Or in simpler terms said, abstract factory design pattern is a way of organizing groups of things that are related to each other. If you have seen my previous video about factory design pattern, you could notice that there is only one single factory class. Inside of that factory class, we have a bunch of if, else, and switch statement based on which it's decided which object of what class do we create. But inside of abstract factory design pattern, we get rid of if, else block and switch statement. Instead, we have factory for each subclass. I know it sounds a little bit confusing, but once we get deeper into a code and see the differences between factory and abstract factory, and we will see the detailed implementation of abstract factory design pattern. There are several components of abstract factory design pattern. Abstract factory, concrete factory for each individual subfactory, abstract product, concrete product, and of course client that will consume that specific abstract factory design pattern and utilize it. So let's deep dive into a code and see how we can utilize abstract factory design pattern and how does it differ to standard factory design pattern. Let's go. Abstract factory design pattern consists of several key components, and that are abstract factory, concrete factories, abstract product, concrete products, and client that will consume that abstract factory pattern. So let's see, this class that I'm currently showing to you is our application or our client that is consuming our abstract factory GUI factory. And it calls .create button and create checkbox methods. So let's go into the GUI factory method, and as you can see, it represents abstract factory class in our pattern. So it's an interface in which we only declare which abstract products do we want to create. So button and checkbox represent abstract products that we want to create. So they are interfaces that have one, two, or several methods depending on our business requirements. And abstract factory only defines methods for creating abstract products, but the implementation of these methods are done in the concrete factories, and that are Mac factory and Windows factory. So both of these factory classes implement abstract factory class, and in our case it's GUI factory, and they override the two methods that we have defined in abstract factory, and that are create button and create checkbox, and they create their own representation, or better to say concrete product of necessary for that method. So here in Windows factory we create a new Windows button, and it represents concrete product that implements abstract product. Abstract product is used in abstract factory. So abstract factory uses abstract products, and concrete factories use concrete products. So Windows factory override both of these methods and creates objects of Windows type, so Windows button and Windows checkbox. On the other side, Mac Factory also overrides these two methods from the abstract factory, but it implement them in its own way. So instead of creating Windows button, it creates Mac button and Mac checkbox. So now when we go to the main class, which represents the client together with the application class that I have defined here, so we can specify name that we want to achieve, that we want to retrieve, and then we say, okay, is it a Mac? If yes, then call Mac Factory. Not, then call Windows Factory. We instantiate concrete factory, which is assigned to the variable factory, and later we can say, okay, factory.paint. As you can see, I have done a little bit here. When I call paint, it will paint my button and my checkbox, but it basically will call the paint method of the abstract factory of GUI factory. So it doesn't have direct communication with concrete factories, instead only with the abstract factory. So what happens if we need to add, let's say, support for Linux? So let's see how we can implement that. If we need to add support for Linux, well, then we make some small changes to the code. So we can say something like this: if name dot contain Windows, else factory equals Linux factory. Since a class does not exist, we need to create it in the concrete factories. We'll say it Linux factory, and it implements abstract factory. In our case, it's GUI factory. It also needs these two methods, and these methods return no Linux button and also concrete product no Linux checkbox. And as you can see, we also need to create these two classes, concrete implementation, and they need to implement abstract product. In our case, button. Implement it. Just write something. Standard output. Linux button. Also to create the same for the checkbox. Checkbox represents concrete product, which of course means that we need to inherit the abstract product, in our case checkbox, and then implement that specific method that we have defined. See, and that's it. And now if we run it, now we start this from the Linux screen. We'll go to here, and as you can see, just with these simple changes, we have added support for Linux operating system. If we run this solution now, since I'm running this from the Windows machine, and since I'm running it from local machine, which is a Linux one, it will display you have created Windows button and Windows checkbox, and the corresponding printout will happen for Mac and also for Linux. The abstract factory pattern makes life easier for the developer and also for the client because it hides messy object creation from the client. Only thing that a client needs to do is to request specific object from the abstract factory, and then abstract factory handles it all. It means that using this design pattern, we create code that is more cleaner, extendable, and flexible. There are also a couple of downsides: increased complexity, increased number of classes, harder to debug since implementation is hidden from the client. But all in all, there are a lot of more upsides than downsides. What are your thoughts about Abstract Factory design pattern? Is it any good? Have you used it in any of your previous projects? Do you find it useful to increase code cleanness, flexibility, and extensibility? Leave your thoughts in the comment below, and don't forget to like, share, subscribe if you would like to see more videos from topics of Java, Spring Boot, and software development in general. See you in the next video.